Hey everyone, welcome back to Simple Learning AI. In our last video, we explored the basics of machine learning. Today, we're diving even deeper, and trust me, this will make everything click even better. We'll break down three major ideas: classification, regression, clustering, simple explanations, real-world examples, and zero stress. Let's jump right in. First up, supervised learning. In supervised learning, the machine learns from data where we already know the correct answers. Let's start with classification. Classification is when the machine's goal is to predict a category or label. It's answering the question, which group does this belong to? Here are some examples. Is this email spam or not spam? Is this a cat, dog, or bird? Does this patient have diabetes or no diabetes? In every case, the output is a specific label, not a number. Now, let's talk about regression. Regression is when the machine's goal is to predict a continuous number. It's answering questions like, how much? How many? What value? Examples include predicting the price of a house based on its features, predicting tomorrow's temperature, estimating a person's age from a photo. The output here is a real number, not a label. Alright, moving on to unsupervised learning, where the machine learns without any labeled answers. One of the biggest tasks here is clustering. Clustering is when the machine automatically groups similar items together without anyone telling it what the groups should be. Examples include grouping customers based on their shopping habits, finding topics in a bunch of news articles, grouping animals by similarities without knowing their species. The machine looks for patterns and naturally separates data into clusters. There are different ways to do clustering, like K-means clustering, hierarchical clustering, DBSCAN. Each method has its own style, but they all share the goal: find hidden groups in the data. K-means is one of the simplest and most popular clustering algorithms. How it works. First, you choose K, the number of groups you want. The algorithm picks K random points as starting centers. Then it assigns every data point to the closest center. After all points are assigned, it recalculates the center of each group. It keeps repeating this process until the groups stop changing. Hierarchical clustering builds a tree of clusters, like a family tree. There are two ways. Agglomerative, most common, start with each point as its own cluster. Then slowly merge the closest pairs together. Divisive. Start with everything in one big cluster. Then split it step by step. At the end, you get something called a dendrogram, a tree diagram that shows which points got grouped together first. DBSCAN is a smart clustering method that looks for areas with a lot of points and calls them clusters. How it works. If a point has enough nearby neighbors, it's part of a cluster. If a point is too alone, it's called noise or outlier. DBSCAN is great because it doesn't need you to say how many clusters you want. Decision trees are a supervised learning algorithm. They rely on labeled data during training to learn the relationship between input features and output variables. This allows them to make predictions or classifications on new, unseen data. A decision tree works exactly the same way for machines. It's called a tree because it branches out starting from a question, called a node, and splitting into different paths based on answers. How a decision tree works. Start with all your data at the top. Ask a question about one feature. Example: is age greater than 30? Split the data based on the answer. Yes goes one way, no goes another. Keep asking questions and splitting until you get pure groups, where all data points belong to the same category or have a similar value. If you enjoyed this video, smash that like button, and don't forget to subscribe for more simple, beginner-friendly AI lessons. Got any questions or topic ideas? Drop them in the comments. I read every single one. Thanks for watching, and I'll see you in the next one. Bye for now.